Hi everyone, today we are going to talk about how to connect synchronous generator in Synchronous with the grid. Today's lab will deal with three different parts. The first part is to connect the synchronous generator in Synchronous with the grid. The second part is how to keep constant excitation. The third part, how to keep constant power. What I need for today's lab, I need the synchronous module. And this synchronous module is helping me to connect the synchronous generator in Synchronous with the grid by changing the location of this guy from on to off. Once I'm seeing all of these lamps are distinguished, at that time I will connect the synchronous generator in the grid. So these three different slots are the power supply that I will use it as my grid. So these three will be connected to those three, and those will be connected to those for the synchronous generator. So I need the synchronous generator, and I will connect the output of the synchronous generator to these three slots, and I need the DC motor to be a prime mover, and I'm going to adjust the field of the DC motor to adjust the speed of the DC motor, and as a result to adjust the speed of the synchronous generator, and by doing that I can adjust the frequency of the synchronous generator. The second thing, how to adjust the voltage for the synchronous generator, I can adjust that by changing the field of the synchronous generator. The third part is the phase sequence. So I will check these three lamps for the phase sequence. If I'm seeing all of these are flashing at the same time and they are distinguished at the same time, that means the phase sequence of the synchronous generator is the same like the grid. But if one is flashing and another one is not, or they are flashing in sequence, it means there is a phase shift. So what I'm going to do, I will switch between two of these two slots connections. So I have three components, changing the frequency to be adjusted to the grid depending on the field adjustment for the DC. The second part, adjust the voltage by adjusting the field of the synchronous generator. The third part is to check these guys. So what am I going to do right now? I'm going to connect my synchronous generator, and I'm going to also connect my prime mover. So the prime mover, like what you are seeing, I will use shunt DC motor, so I will connect this guy in parallel with this, but I would like to adjust the field for the DC motor to adjust the frequency. So I will use the rheostat for doing that. So I will connect this guy in series, and then this guy will be connected in shunt or in parallel. At that time, I'm connecting my DC motor in parallel, so I have armature connected in parallel with the shunt field, and I have this rheostat to adjust the speed. The next step is to feed these 2 points or these 2 points by a DC source, and the DC source that I'm going to use is a fixed DC source, because I can adjust the value by the rheostat. So I will connect this 8 to this 8, which is fixed, and I will connect this guy to this guy. At that time, my field is fed through these two. But I don't like these to be so tight, so I will change this by another one. So I will use these two. And I will use this one as well. So like what you are seeing, the DC is connected to the power supply. What is the next step? I would like to measure the current to this guy. So for measuring the current to this guy, I'm going to use a meter. So I'm going to use this guy to measure the current by using the data acquisition system. So I will disconnect this. So I will connect my ammeter between these 2 points. This will be my ammeter for measuring the current. This is the DC machine, so if I try to turn it on, the DC machine is working, but I didn't do anything for the synchronous machine. So the next step is to connect the synchronous machine. I need to make this guy star. So this is the stator, it is connected star, and then those three will be connected to the synchronizing module. So I will connect this guy, and this guy, and this guy as well. Those three will be connected to the synchronizing module. So I will connect 1 to 1, and 2 to 2, and the 3 to 3. But I didn't generate the flux, so I need to connect the DC field to these two points, which is representing my power supply for the field. So I will connect this guy to this guy, and this guy, I will connect it to this guy. This is the field. Now, the next step is I would like to measure the armature current and the terminal voltage. So for measuring the armature current, I'm going to deal with one of these three. So I'm going to reconnect this guy again, because I would like to connect a meter between these 2 points. So I will bring another wire, and in between those, I'm going to connect this ammeter. So the current here is the armature current, and I would like to measure the voltage as well. So I will bring another wire for measuring the voltage. So I would like to measure the phase voltage. So I will connect this to this. These two are measuring the phase voltage. I will connect them to E1. If you would like to measure line-to-line voltage, you will connect your voltmeter between these 2 points. But here I'm connecting my voltmeter between these 2 points. At the same time, I would like to measure the grid voltage, but this is what I'm going to do next after connecting these three to these 3 points. So I'm going to connect the power supply, which is considered as the grid. 5 will be connected to 5, and 6 will be connected to 6. Then I would like to measure the phase voltage, so I will connect between these 2 point voltmeter. If you would like to measure the line voltage, you will connect a voltmeter between these 2 points. So I'll bring another wire to measure the voltage between this guy and this guy. So these 2 wires are measuring the voltage E2. So this is AC volt, and this is AC volt, and this voltage and this voltage, this guy is measuring the voltage for the synchronous generator, this guy is measuring the voltage for the grid. And I will adjust my data acquisition system based on that. So E1, like what you are seeing here, is measuring the voltage for the synchronous generator, and E2, which is this guy, is measuring the voltage for the grid. Once they are equal, this is the first condition, I can connect if the second 2 conditions are valid. What I need else for the connection, I will try to connect my circuit and see. But before leaving that, here I adjusted the frequency of the grid, which is F for E2 and F for E1. F for E1 is the frequency for the synchronous generator, and for E2, the frequency for the grid. And here also, I'm trying to measure the current I1, which is the synchronous generator current, which is IA small. And I'm trying to measure I2. Where is this guy. I'm trying to measure this guy, which is I3, which is the current for the field, for the DC. I would like also to measure the current for the field for the synchronous generator. So I need one more wire. And what I need here, instead of connecting this guy directly to N, I will disconnect it. And I will put in between these 2 points another ammeter, and this ammeter is DC ammeter because it is measuring the field for the, it is measuring the field current for the synchronous generator, which is DC, which is I2, so I will adjust it. I would like also to measure the power between E1 and I1, so I adjusted this guy for the power. It could be measured active, reactive, or S. I will measure the active, and then I'll see. So what I need right now, I will try to see the synchronous generator, and I will try to see my readings here. I'm seeing negative sign here because of the connection of the ammeter. This is DC. I can switch between them. But like what you are seeing here, the frequency for the grid is 60 and the frequency for the synchronous generator is 70. So I can play with the frequency by adjusting the speed of the DC motor, which is the prime mover. And this is what I'm doing here. I'm reducing the frequency till it became the same like the grid. I think it is almost 60 like the grid. And if you try to use the tachometer to measure the speeds, the speed is almost 1,800. So right now I have the frequency for the grid. It's the same like the frequency for the synchronous generator. But what I would like to measure as well, I would like to measure the voltage for the grids and the voltage for the synchronous generator. What I'm seeing here, I'm seeing the voltage is not the same. So I will try to adjust the voltage of the synchronous generator and the grid. Here, I'm measuring the phase voltage. The voltage that I have right now is 108, almost 110 for the grids. But the problem is that I have difference for the voltage between E1 and E2. E1 is representing here, E1, it is representing the voltage for the synchronous generator, and E2 is representing the voltage for the grid. The grid is 120, but the synchronous generator is 108. So I can adjust this guy by changing the field for the synchronous generator. Like what you are seeing, I try to adjust the voltage. Now, the voltage is almost similar. What you are seeing here, all of those are flashing at the same time, are shining at the same time, they are on and off at the same time, which means the phase sequence is the same. Let me switch between these two to show you if the phase sequence is not the same, what's going to happen. See here, they are flashing in sequence, which means the phase sequence is not the same. So to overcome that problem, what I have to do, I will switch between those. Now, they are flashing at the same time, they are on and off at the same time, and everything is okay, so the frequency is the same like the frequency for both of them, the voltage is the same, and the same phase shift. At that time, I can connect my synchronous generator in synchronous with the grid, and I will not hear noise. I will stop talking, and I will show you if I connected this, if you are going to hear any noise or not. See? We didn't hear any noise because I'm connecting them at the perfect timing. But if I tried to connect them while they are shining, there is a little difference between the voltage or the frequency for both of them. Let me make a little change for this guy. And try to connect them while the lamps are shining, they are not off. Here, there is a noise. I don't know if you hear that or not. Let me make more change. So I will try to connect it. There is a big difference between the voltage. You will hear noise. I think you hear that noise. Let me repeat it again. See what happened. This is the first part of the lab, but let me adjust it again to be the same like the grid, because I need to continue talking about that lab. So this is the first part of the lab. The next part of the lab is to do what? I would like to change the field current for the DC machine, because I would like to work under constant excitation for this guy. So I will not play with the excitation, and I will try to adjust the speeds, and I will try to measure the currents IA capital for the DC field, and IA for this guy, which is the synchronous generator, IF, which is this guy, and I would like to measure the power factor, and I would like to measure the power. So everything here I recorded it. So I will try to change this guy and take different readings for that. But I'm doing that by keeping the excitation constant. So I'm not changing this guy for the synchronous generator. Then I would like to work again for constant power. So I would like to make this current 1 ampere and 2 ampere for two different cases. So I will change this current to be 2 ampere. And then what I'm going to do, I'm going to change the excitation, and I will try to measure IA and P and Q. But don't forget, I would like to measure as well delta. So if you try to measure delta, what you have to do, you will use a strobe meter for flashing, and here I have phase shift indicator. To measure delta, I think you are not seeing it because of the flashing, but I took a picture for that. And this is the end for that lab. I would like to connect the synchronous machine in Synchronous. I'd like to keep the excitation constant, and I would like also to keep the power constant for different values. This is the end of today's lab, and I'll see you for the next lab. Bye for now.